Let's talk about colonizing a planet, specifically Mars. The idea of leaving Earth behind and establishing a human presence on another planet has long been a fascination, and Mars has been a focus for potential colonization. However, there are numerous challenges and dangers associated with settling on Mars. One of the major obstacles is the harsh Martian environment. Mars has a very thin atmosphere with less than 1% of Earth's atmospheric pressure. This means that humans cannot survive outside of a pressurized environment, and liquid water is not possible on the surface due to the low atmospheric pressure. Mars is also known for its massive dust storms, which can cover the entire planet and pose a risk to technology and human health. The dust on Mars is electrostatic and toxic, making it a challenge for any equipment or structures on the surface. Another significant concern is cosmic radiation. Mars has very little protection from solar radiation due to its thin atmosphere, and the long-term effects of exposure to cosmic radiation on humans are still unknown. The first colonists on Mars would be exposed to higher levels of radiation, and it could have potential health implications. Despite these challenges, the concept of terraforming Mars, making it more Earth-like, has been proposed. However, it is a complex and currently unproven idea. Mars likely lost its atmosphere over billions of years, possibly due to the absence of a strong magnetic field like Earth's. Restoring the atmosphere would be incredibly difficult, if not impossible. Some suggestions, like nuking Mars to release greenhouse gases, have been proposed but are unlikely to work as intended. In terms of colonizing Mars, there are ongoing efforts to develop technologies and strategies. NASA's Perseverance rover has conducted successful experiments with the Mars Oxygen In Situ Resource Utilization (MOXIE) instrument, which can produce oxygen from the Martian atmosphere. This could potentially provide a valuable resource for future human settlements. Additionally, there are ideas for constructing habitats using Martian materials such as basalt, which could be 3D printed and provide protection from radiation and extreme temperatures. Living arrangements on Mars would likely involve underground habitats to shield from radiation and provide a more stable environment. Autonomous robots would likely be employed for surface work and construction, while humans would live and work in the underground facilities. NASA is also conducting studies to understand the psychological and physiological effects of long-duration space missions through simulated Mars missions. In terms of power generation, solar energy has been the primary source for the Mars rovers, but it faces challenges such as dust storms and the planet's distance from the Sun. Elon Musk's Tesla, with its expertise in solar power generation and battery storage, could potentially contribute to solving this issue. Alternatively, nuclear power has been suggested as a more reliable energy source on Mars. Overall, colonizing Mars is an ambitious and challenging endeavor, but human innovation and advancements in technology may pave the way for a multi-planetary existence. Collaboration and continuous research are crucial to overcoming the difficulties associated with settling on Mars and extending humanity's presence to other planets. The idea of using nuclear power on Mars is not as far-fetched as it may initially seem. In fact, it has been proposed as a potential solution to the energy needs of a Martian colony. Nuclear power offers several advantages over other forms of energy generation. Firstly, nuclear power provides a high energy density, which means that a relatively small amount of nuclear fuel can generate a large amount of electricity. This is particularly important on Mars, where resources are limited and transporting large quantities of fuel from Earth would be impractical. With a compact nuclear power system, a Martian colony could generate sufficient electricity for its needs. Secondly, nuclear power is not reliant on external factors such as sunlight or wind, which can be unpredictable on Mars. It can provide a stable and consistent source of power regardless of the time of day or weather conditions. This reliability is crucial for sustaining a human presence on the planet. There are different types of nuclear power systems that could be considered for Mars. One option is a small modular reactor, SMR, which is a compact and self-contained nuclear power plant that can be transported and installed on-site. SMRs have the advantage of being scalable, meaning that multiple units can be deployed to meet increasing energy demands as the colony grows. Another possibility is using advanced nuclear technologies, such as nuclear fusion or advanced fission reactors. These technologies are still in the experimental phase on Earth, but if successfully developed, they could offer even greater efficiency and safety compared to traditional nuclear reactors. Of course, implementing nuclear power on Mars would come with its own challenges. Safety would be a primary concern, as any malfunction or accident involving a nuclear reactor could have serious consequences. Robust containment systems and strict safety protocols would need to be in place to ensure the protection of both the Martian environment and the colonists. Additionally, the construction and deployment of nuclear power systems would require advanced engineering capabilities and infrastructure on Mars. This would involve significant investment and technological development before such systems could be realized. Overall, while nuclear power presents potential advantages for energy generation on Mars, it is a complex and multifaceted issue that would require careful consideration and planning. However, given the challenges of alternative energy sources on the Red Planet, nuclear power remains a promising option for providing a reliable and sustainable energy supply for future Martian colonies. One of the key challenges in establishing a sustained human presence on Mars is the availability of resources, including energy. Mars has a thin atmosphere, low sunlight intensity, and frequent dust storms, which pose challenges for traditional solar power systems. While solar power can still be utilized on Mars, nuclear power could serve as a complementary or alternative energy source to ensure a reliable and continuous power supply. In addition to providing electricity, nuclear power could also be used for other essential purposes on Mars. For example, nuclear reactors could generate heat for various applications, such as melting ice for water extraction, supporting greenhouse agriculture, or even producing propellant for return missions. This versatility makes nuclear power an attractive option for long-term sustainability on the planet. Another advantage of nuclear power is its potential to support in-situ resource utilization, ISRU. ISRU involves utilizing local resources on Mars to reduce reliance on Earth for supplies. Nuclear power systems could leverage the availability of water ice on Mars to extract hydrogen and oxygen through electrolysis, enabling the production of rocket propellant locally. This would significantly reduce the cost and logistical challenges of transporting fuel from Earth for return missions. Moreover, nuclear power could provide a means to sustain a long-duration human presence on Mars. As a self-sustaining energy source, it could power life support systems, enable scientific research, facilitate manufacturing processes, and support infrastructure development. This would greatly enhance the capabilities and autonomy of Martian colonies, reducing the need for continuous resupply from Earth. However, there are several important considerations and potential drawbacks to address when contemplating the use of nuclear power on Mars. These include safety. Ensuring the safe operation of nuclear power systems is crucial to protect both the environment and the inhabitants of Mars. Robust containment measures, fail-safe mechanisms, and rigorous safety protocols would be essential to mitigate risks associated with radiation, accidents, or system failures. Waste management. Nuclear power generates radioactive waste, which needs to be handled and stored properly to prevent contamination. Developing effective waste management strategies on Mars would be essential to prevent any harm to the environment or future human settlements. Construction and transport. Building and deploying nuclear power systems on Mars would require significant engineering expertise, advanced manufacturing capabilities, and transport infrastructure. Developing these capabilities would be a significant technological and logistical challenge. Public perception and acceptance. Nuclear power has been a subject of public debate and concern on Earth, and similar discussions would likely arise regarding its use on Mars. Public perception, acceptance, and consensus building would be crucial in shaping the decision-making process and ensuring transparency. As we explore and plan for a human presence on Mars, nuclear power presents a compelling option for meeting the energy needs of Martian colonies. Its high energy density, reliability, and potential for in-situ resource utilization make it an attractive choice. However, careful consideration of safety, waste management, construction, and public acceptance would be necessary to harness the benefits of nuclear power while minimizing potential risks.